So far we had 3 lectures on Aryabhatiya. So in this fourth part I will be definitely concluding Aryabhatiya, and then we will move on to a bit of Jaina mathematics. So in the last lecture on Aryabhatiya, so I was explaining to you about the methods by which Aryabhata has derived the sign tables, so he has suggested, and then we also saw certain gnomonic problems. So problems that can be handled with the Shanku, we saw a couple of Nyayas, and in this lecture I will basically start with the series. In fact, I touched upon the arithmetic progression which has been dealt by Aryabhata too. So in fact, there are a few other problems which I am skipping on Ganitapada. So I will be just highlighting 2 more problems, and then I will move on to the last part of Ganitapada, which discusses the Kutarka problem. So Kutarka is a very interesting terminology which has been used to refer to a certain process, so by which we will keep on reducing the numbers. So Kuttanam is basically, so hitting on the head, in Tamil Kutraduna, so that is what it is. So it is basically pounding or pulverizing, so things are just brought down, okay. So that is perhaps the origin of the term Kutarka. So the formulation of the problem, then I will give you an example of how it has been used in astronomy. In fact, the very purpose of the Kutarka seems to have been to solve certain problems in astronomy. We will see a single example from Bhaskara's commentary, and then I will explain in great detail the couple of verses, so through which Aryabhata has presented this Kutarka algorithm. So then I will have an example, then we will move on to Jaina mathematics. See, when I say Jaina mathematics, so I refer to the earlier part of Jaina mathematics. The earlier part of Jaina mathematics has not been in Sanskritam, so it is in Prakrit, Gatha, etc. So it is a bit difficult to decipher the texts themselves, and the texts themselves are not available, and some of the commentaries are taken as the resources for deciphering what has been there in the Jaina, earlier Jaina texts. So with this I will first of all introduce an interesting verse from Aryabhatiyam. This verse is presenting a formula by which we will be able to find out the number of terms given an arithmetical series, given that you know the sum of the series and first term and the common difference. So the verse goes like this: Gachoshtotara gunitat Dvigunad Yuttara Vishesha Vargayutat Moolam Dvigunad Dyunam Swottara Bhajitam Sarupardham. Gachaha refers to the number of terms in an arithmetic series. Gachaha. Okay. So Ashta Uttara Gunitat. So in fact, in the previous verse, so we had the sum mentioned, the sum of the series, the formula for finding the sum mentioned, and therefore in this verse, so it is not explicitly stated, but since Aryabhatiya, as I was mentioning earlier, is more or less composed in sutra style. In sutra style, so we have something called adhyahara. So whatever is not presented in this sutra, and if it is available in the previous sutra, we borrow it. So this is the kind of thing which seems to have been done here, and since he was speaking about the sum in the previous verse, so here we have to take the sum. So Gachaha Ashta Uttara Gunitat. So Ashta is 8, Uttara is the common difference. So Gachaha, Gachaha, so we have to just split it up. Ashtottara Gunitat, then Dvigunad Yuttara Vishesha Varga Yutat. Adi is the first term, Dviguna Adi is 2 times A. Uttara Vishesha, so Vishesha, as I was mentioning, is difference. Okay. So Dviguna Adi Uttara is 2A minus D, and then Varga is square, Yuta is addition. So this term 8SD is added to 2A minus D square. So this is what it is, Dvigunad Uttara Vishesha Varga Yutat. Then what is to be done? Moolam, you take the square root of that, Dvigunadi Unam, so minus 2a, Moolam Dvigunadyunam Svottara Bhajitam. So Swam here refers to the, so the series as such, Uttara is, so the common difference in the series that forms the divisor. Then the last term is Sarupa Ardham, Sarupa is, Rupa is 1, so Sarupa is, so Rupena Saha, so add 1 to that, and then he says Ardham, so you have to divide by 2. So this basically gives the number of terms in an arithmetic series provided you know S, D and A. So this is the formula which has been given. It is an interesting thing to see why Aryabhata has specified this in this particular form. It has been commented by Nilakantha, wherein he has shown a certain way of proving this result, not by algebra but by geometrical construction. Okay. So you can think of so cube piled upon. So in fact a series can be considered to be Shredhi. Shredhi is step by step. So a plus d and so on. So similar kind of construction can be used to actually show this result. So this result as such looks complicated, and if one were to show, this can be of course written in various ways. So the right hand side so can be written in various ways, and this particular way in which this has been written seems to be stemming from the fact that they might have had a certain way of looking at it, and that has been shown by Nilakantha, so which I am not discussing right now. Certain algebraic identities have also been presented by Aryabhata. So this is just a sample which I want to give. Aryabhata has also discussed rule of 3, of course. So Professor Sriram, so in his talks will be covering all that in great detail, but this being the earliest text, so I wanted to present more or less so on various issues which Aryabhata has discussed. Suppose you know the product of two numbers and you also know the difference. So this is the kind of problem which Aryabhata has chosen here. Will you be able to find out those two numbers? So this is the question. If x minus y is a and xy is b, then how do you find xy? So this is the relation which has been given by Aryabhata in this verse. He says Dvikriti Gunat. So Dvikriti, Dvi is 2, Kriti is square, so Dvikriti is 2 square, which is 4. Guna is multiplication, Dvikriti Gunat Samvargat. Samvarga I have been repeatedly saying is product. So suppose you know the product of two numbers, and that product he refers to as Samvarga, xy let us say is b. So Dvikriti Gunat, so if you look at this expression, so which gives the value for x and y, the first term is Dvikriti and then Samvarga Guna, okay, 4 times b. Dvikriti Gunat Samvargat Dvyantara Vargena. So the two numbers which you consider, Dvyantara is the difference of the two, Varga is square, so Dvyantara Vargena Sanyutat. See, you have to add this and then you take the square root, Moolam Antara Yuktam Heenam. See, Antara is difference Yuktam, okay. So Antara Yuktam Heenam, so Gunakara Dvayam Dalitam. Dalitam is half of it. Okay. So this is this is one of the algebraic identities which he presents, and this may be useful in various contexts. So these algebraic identities have also been presented in the form of verse. So I mean, like we memorize what is the value of x in a quadratic equation, so minus b plus r minus root a. So that is the kind of thing. So this has been presented in the form of verses. Now I move on to the Kutarka algorithm. So this Kutarka algorithm is primarily a method by which you will be able to find out solution to the first order indeterminate equation. Okay. So the indeterminate equation will have two variables in this and it is first order, we have just two variables, and a step by step procedure has been delineated by Aryabhata in two verses for solving this equation. And why were they worried about solving this? I will show you through an example the context in which they had to necessarily find a solution for this. So, this is primarily to solve astronomical problems. So, Kutarka is referring to the process of pulverizing something. So, basically a repeated operation. So, even hammering, so something is a repeated operation. And here what we do is, so given two numbers we will keep on successively dividing one by the other. So, this can be thought of to be similar to the Euclidean algorithm, and by mutual division we will keep on reducing the magnitude of those two numbers, and at some stage we will stop this. So, it can be stopped at any stage, and then you can go and construct what the two numbers x and y are. This algorithm also plays a very key role in solving Varga Prakriti, which I will also be discussing a little later when we discuss about Brahmagupta, and it will also be touched upon by Professor Srinivas. This Kutakara occurs in various contexts. So, therefore, Bhaskara classifies this Graha Kutakara, Rashi Kutakara, Lipta Kutakara, Vara Kutakara, and so on and so forth. If it is arising in the context of dealing with the revolution number of planets, you call it Graha Kutakara. This can arise in various occasions. So, suppose you want to express some magnitude in terms of degrees, some in some other magnitude. So, if you have to handle those two, so again there will be a Kutakara. So, Rashi is basically some number. So, Rashi, Lipta, so all that requires a Kutakara method. So, to place the problem in more concrete way, so let us consider a number n. So, this is how it can be easily understood. There are different ways in which this Kutakara problem can even be presented, but we choose one particular way which is very close to the method which has been described by Aryabhata. Suppose there is a number n, and this number when divided by a, it gives some value, and when divided by b, it gives some other value, and then plus some remainder, the quotients plus some remainder. So, n is equal to ax plus r1 is also equal to by plus r2. So, it can be easily seen that so this can be represented in this particular form. We choose this way, by minus c is equal to ax, where c is the difference of the two remainders r1 and r2. So, the problem is given a, b and c. So, we have to find integer solutions for x and y. So, this is all Kutakara is all about. So, this is an indeterminate equation, because we have only one equation and we have two variables. So, therefore, it is not so trivial to find a solution in all the cases. In certain cases we can easily guess the solution, but in most of the cases it will not be trivial, and we need a certain systematic procedure by which we will be able to solve this equation. From the viewpoint of history, this equation has been generally referred to as Diophantine equation, so which is not quite correct. So, if one were to look at from the historical viewpoint, in fact Diophantus also attempted a slightly different kind of a problem. He was not even trying to find integer solutions to this problem, he was trying to find rational solutions, and rational solutions are far more easier than getting integer solutions for this problem. So, so, I will give you the example, one of the examples which has been presented by Bhaskara to give you a flavor of the context in which this Kutakara problem arises in astronomy. In fact, Bhaskara says Graha Ganite Kutakaro Yojyate. So, he will say Graha Ganite Yojyate, so Lipta Ganite Yojyate, Rashi Ganite Yojyate, so all that he says. So, Graha Ganite I am trying to present you how Kutakara arises. Pravibhaganaha kena gunitaha mandalashesham apaniya bhudivasanam shuddham bhagam dadyuriti. This is the problem. So, Ravi Bhagana is basically the number of revolution made by the sun. So, Ravi Bhaganaha kena gunitaha multiplied by which factor mandalashesham apaniya bhudivasanam shuddham bhagam. In fact, this is a very important problem in the sense that Indian astronomers have presented a very large period. So, this for you to have a much general picture, I just wanted to spend a couple of minutes. So, you have a very large period, so you can call it Kalpa, you can call it Mahayuga, whatever be the period that you want to define, let us define this. And this large period is to see that, so the various planets which are moving in various orbits, so they complete some integral number of revolutions. So, there will be some remainder here, some remainder there. So, now you have to see to it that you will be able to get a certain period by which all of them can make integral number of revolutions. So, it is in this context this Kutarka naturally arises. Okay. And here Bhaskara says Bhudivasa is basically the number of civil days. So, by number of civil days I mean the number of sunrises that take place in a given period. See, when sun starts moving or moon starts moving, so it may start at a particular point, so it will make some n number of revolutions, and when it comes back, so it need not be the same time. So, can we see to it that after making integral number of revolutions, can we fix a certain period by which this will also complete integral number of revolutions and something else also will do. So, that is the kind of context in which this arises. He says Madhyam Ravehe Mrigapato Dhanuramshakardhe Drishtam Maya Dinakarodaya Kala Jatam. So, Dinakarodaya Kala Jatam means, so Dinakara Udaya, so when it rises. So, I just take the beginning of this period. So, Aganyatam Dinaganaha Bhattashastra Siddha, this Bhattashastra refers to Aryabhatta Yatascha Tasya Bhaganaha Kalikala Siddhaha. So, this is the kind of problem which Bhaskara wants to attempt with the reference to the number of revolutions made by the planet. So, now we move on to the Kutarka problem as such. So, and the solution which Aryabhatta gives. These verses are not very easy, so you may have to follow it carefully, because the kind of compounds which Aryabhatta has formed and the terminology which he has employed may not be that familiar even to those who are fairly conversant with Sanskrit. So, Adhikagra Bhagaharam Chindyat Unagra Bhagaharena Shesha Paraspara Bhaktam Matigunam Agrantare Kshiptam. So, this is the first half of the algorithm which has been given by Aryabhatta. So, then the later half completes the whole algorithm. The term Agra normally means, so a tip kind of a thing. So, here this has been used in the sense of getting a reminder. See, suppose you think of, so representing a certain number, so by this magnitude. So, if you keep on dividing this, there will be some remainder which comes. So, this is the tip that he means. So, by Agra he means remainder. Okay. If you go back and then see this, see, so n is equal to ax plus r1 and by plus r2. So, r1 and r2 are referred to as Agras. So, Adhikagra, if r1 is greater than r2, so you call r1 as Adhikagra and r2 as Unagra, fine. So, Adhikagra Bhagaharam Chindyat means, so may you divide. So, okay, Chedanam is cutting. So, cutting is referring to the process of division here. So, in fact, Bhaskara starts his commentary by saying Agram Sheshaha. So, in common language we call it Sheshaha, but Aryabhatta has used the term Agra. So, Agram Sheshaha, Adhikagram, so for which the remainder is large, okay. Adhikagra Bhagaharam. So, here, so this is a compound Bhagaha Hriyate Yasmat. So, that is how we need to understand. So, the number, so which is being divided, okay. So, in Sanskrit you can form various kinds of compounds. So, Rameshwara, when you say, so Rama is Ishvara is one way of saying, or you can say for whom Rama is Ishvara. So, all that can be said. So, here Bhagaharam should be understood as Bhagaha Hriyate Yasmat, it should be taken as a Bahuvrihi compound. So, from which we are removing the part, so which means it is the dividend. So, Chindyat, may you divide. When you say divide, divide by what? So, bhagaharena, see unagra bhagaharena, okay, by the other number for which the remainder is small. So, unagra bhagaharena chindyat. So, the process does not end there. So, this is the initial stage in which you get the first quotient. So, then you will get some remainder, take the remainder and then you divide the number by which you divided before. So, the process is going to be repeated. So, for you to see, this is the kind of thing. Suppose A is adhikagra, B is unagra. So, you have to do this. So, this Q is the first quotient and then so R1 is the remainder, you once again divide B. So, you will have something R2 is the remainder, you should keep on doing the process. So, this is what is referred to by Aryabhata Shesha Paraspara Bhaktam when he says. So, Shesha is remainder. So, Paraspara Bhaktam is, so the previous remainder is going to become the dividend now and this remainder, so by which you divide will become the dividend in the next stage. So, you have to do it continuously. Shesha Paraspara Bhaktam. Then when you reach a certain stage, so this can be terminated and at that stage, so he says you have to do a certain process, that process is Mati Gunam. So, Mati Gunam is multiplication. So, Mati Gunam means multiply by Mati, okay, Matya Gunanam Kartavyam. So, that is Mati Gunam. Okay. So, what is this Mati? Mati normally means Buddhi, intellect. So, here he has used that word to refer to a certain number which you are going to guess by making use of your Buddhi. So, that is why he is calling it as Mati. So, Mati Gunam means a number which you will guess. So, you have to make a guess so that the product of this Mati and the remainder that you have, so minus or plus something will be the divisor, will exactly be multiple of something else. Okay. So, just keep it in mind, as we see the algorithm it will become clear, but Mati is basically referring to a number which you have to guess at a particular stage. So, you can stop the division at any stage in fact. So, if you carefully analyze the algorithm, it is a very beautiful algorithm. So, Mati Gunam multiplied by Mati. So, that is why it is called an optional number. Agrantare Kshiptam. Agrantara, so I told you Agra refers to remainder, Agrantara is difference of the remainders. So, that is what is denoted as C. See, the C refers to R1 minus R2, Agrantara. So, Agrantare Kshiptam. So, all that he says is, so you have to get a Mati and this Mati has to be multiplied by some number and to that this Agrantara has to be, Kshiptam means thrown, okay. Agrantare Kshiptam, so basically it could be either addition or subtraction, okay. You have to do either addition or subtraction, the Kshiptam is referring to either of them, that we understand only from the commentaries. Agrantare Kshiptam. In fact, it says Katham Punaha Swabuddhi Gunaha Kriyate Ayam Rashihi. See, so he beautifully says Bhaskara, Ayam Rashihi, this number, Kena Gunitam, multiplied by what? Idam Agrantaram Prakshipya. See, you have to multiply this Rashi by some number. So, and then plus or minus C, Vishodhyava, see, Prakshipya Vishodhyava, Asya Rashehe Shuddham Bhagam Dasyati. Shuddham Bhagam means, Bhagam is basically the quotient, Shuddham Bhagam means without any remainder. So, it is perfectly divisible, that is what it means. So, then he also says Sameshu Kshiptam Vishameshu Shodhyam. When should you add C, when should you remove C? Sama is even, Vishama is odd. So, when the number of quotients that you have, see depending upon the process, so you will get a certain number of quotients. If the number of quotients is odd, you have to do something, if it is even you have to do, and he says Sama, if it is even, Kshiptam you have to add, when it is Vishama you have to remove it, okay, Shodhyam. So, how do you know this? There he says Sampradaya Avichhedat. So, Aryabhata has worked out, this is how it seems to be. So, it is a Sampradaya which has been handed down to us, okay. Traditionally they have discovered this to be the method and therefore we interpret it that way. So, Vyakhyayate, this is how I explain this. Okay. Now I move on to the second part. See, in fact, at this stage of the verse, we have to see the commentary, because what is to be done with all this? So, that has not been very explicitly stated by Aryabhata in the verse, and therefore, something has to be uhyam. Okay. So, uhyam means to be guessed. So, evam parasparena labdhani. Okay. If you divide, so you will get a set of quotients, labdhani, padani avasthapya. So, you have to arrange them in a particular way. This has not been stated in the verse. So, that is why the commentator states something has to be uhyam, means you have to make a guess. So, padani avasthapya matischa adhaha. So, I will quickly tell you, so you can keep this in mind and then you can understand the verse. So, we did a series of divisions. So, we got a series of quotients. So, all that has to be done is you have to arrange them one below the other. See, q1, q2, blah 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 and so on. So, qn, let us say up to that. So, one below the other you have to arrange. So, this is generally referred to as valli. Valli means a sequence. Okay. So, all the quotients form the sequence, and then below that you have to place this mati and then some other number s. So, which is actually the quotient which is obtained by doing this operation. So, I said you have to make a guess of mati. So, mati into what is to be done is the last remainder that you get. So, this I am denoting as, see, for instance, so you have this division process denoted here, and the last remainder is, so let us say r 2n plus 1. Now, r 2n plus 1 into mati. Okay. So, this is the guess. So, the number that is guessed. So, how should you guess? You should guess in such a way that r 2n plus 1 into t plus c is divisible by r 2n, the previous. Okay. So, this is the algorithm. So, that is something which has not been stated in the. So, that particular mati also has to be placed, avasthapya one below the other you have to place, matischa adhaha you have to place the mati below, and paschima labdhancha matyaha adhaha. Paschima labdham means once you guess this mati and then plus minus c, if it is divisible by some other r 2n, so then that quotient is what is referred to as paschima labdha here. Paschima labdha means after making guess of mati and after doing this division, whatever be the quotient. So, that is the ultimate thing that you find out in the process. After that, it is a matter of multiplication and getting the value of x and y. So, the process as such ends here, and therefore, paschima labdham, that which is obtained later, matyaha adhaha you have to place that also below. So, that is how it is. See, get all the quotients, place one below the other, place mati and place the quotient that you get by doing this process. Okay, matyaha adhaha. Then what is to be done? So, this is the arrangement. So, till that is over. Now, I am moving to the second verse which is given by Aryabhata. So, adha upari gunitam. So, having created this valli now, so what is to be done? Adha upari gunitam. So, the number which is there, penultimate number has to be multiplied by the previous number. Upari gunitam means you multiply the number which is above that, and then antya yuk. So, below that you place the quotient. So, you have to add that also. So, to show you here, if you have done this, so at this stage what you have to do is you have to take a product of t and qn, q2n. This is adha upari gunitam multiply, and then whatever is below it you have to add that. So, this is how he describes the algorithm. Adha upari gunitam antya yuk. Okay, add the antya. Unagra chheda bhajite shesham. So, the process is more or less over. So, unagra chheda bhajite. So, he says, so this has to be divided by b. Unagra is smaller remainder. So, in fact, both a and b are referred to as chhedas. So, you may think that see, for instance, if you look at this, so a is divided by b. So, how can this be called chheda? In fact, both are chhedas in the sense of the main problem that you consider. See, if you consider the main problem, So, A is divisor for this, B is also divisor, you have to get x and y. Okay. So, therefore, both are referred to as chedas here. So, unagra cheda bhajite shesham. So, whatever comes as a remainder adhikagra cheda gunam. Okay. So, this has to be multiplied by the adhikagra cheda. See, you find a cheda being used here as well as here, one should not get confused. So, unagra is also cheda, adhikagra is also cheda with reference to number n, but at a later stage, so B becomes the divisor and A becomes the dividend, that is a different thing. Okay. So, unagra cheda gunam dvichedagram adhikagra yutam. So, when you add A to that, then you will be able to get xy. So, this is the algorithm which has been described in 2 verses by Aryabhatta. So, I will leave this. So, this is just the process of division which has to be done and all the quotients are obtained. So, you have to leave the first quotient. So, when you count the number of quotients, see, this is something which has to be kept in mind. The prescription is, so the C has to be added provided the quotients are even, and C has to be subtracted provided the quotients are odd. So, in doing this, one should not commit the mistake of taking Q also into account. So, it is only after this, so the number of quotients have to be counted. So, the division of A by B should be left out. Okay. So, this is how things are arranged, and Q1, Q2, Qn minus 1, Qn, T is Mati and then this. See, now what is to be done? Having created this Valli, so you have to multiply this by this. So, Qn into T plus S. So, let us call this as beta 1 and then the rest have to be just placed like this. So, when you move on to the next stage, so this will be multiplied by this and then T will be added and then this will go on. See, so Qn minus 1 into beta 1, this quantity plus T. So, this is the algorithm, and then when you reach the stage where you have only 2, there is nothing more to be added, you understand. So, at this stage you stop this multiplication and creating the table valleys. So, this is the series of valleys. So, having done this, so finally he says, see, if you look at the verse, so antyayuk, once you do that, unagra cheda bhajite shesham. See, so unagra cheda bhajite means, so this has to be divided by B. B was referred to as unagra cheda. Okay. So, A was adhikagra cheda. So, divide by that. So, the remainder whatever you get, that is basically x. Okay. So, we wanted to find out x and y. So, he described a certain process and he says after you reach these 2 numbers, so then you make the product of this, the last number with B, and when you divide that, so the whatever remainder that you get is basically your x. Okay. So, and n is equal to Ax plus R1. So, let us take an example. So, let us have this equation 45x plus 7 is equal to 29y. So, what do we do? So, we start this division process. So, 45 divided by 29, what you get is 1 and then remainder is 16. So, you take this as the dividend now. So, divide, you get 1 here, again 16, remainder is 13 and so this 16 becomes the dividend now. So, you have 1, so you have 3 as the remainder. So, then 13 becomes the dividend. So, you have 4 as the quotient. Fine. So, how many quotients do we have in this? Is it odd or even? We have 1, 2 and 3. So, this is the case of having odd number of quotients. So, what was the prescription? The prescription is when you have odd number of quotients, the C factor has to be subtracted. Before that, we need to make a guess of T. So, this number, so now we have arrived at a situation where we can form the Valli. So, for forming Valli, I should plus Q1, Q2 and so on. I have to make a guess of this Mati now. So, this remainder, last remainder is 1. So, 1 times t minus 7 should be divisible by the previous remainder. So, you can easily guess that it is 10 will satisfy this. So, t is 10. So, I just put it as 10. So, when I divide by 3, the quotient that I get is 1. So, because it is 3, so you just have 1 as the last thing. So, this is how it has to be arranged. So, at this stage, so having formed this, it is just a matter of simple multiplication and then creating further valleys. See, so 10 times 4 plus 1, so that will be this number. So, this has to be taken as it is. Then 41 times 1 plus 10, that will be this number. So, 41 has to be taken as it is, and then 51 will be taken as it is. So, 51 times 1 plus 41 is 92, over. So, all the Valli operations are over. So, finally, having reached this stage, what is to be done? Take the last number 92, and then it was said, if you look at the verse, so he says Antiyuk Unagra Cheda Bhajite Shesham. So, Unagra Cheda Bhajite. So, this is basically dividing by Unagra Cheda. So, 92 has to be divided by 29. So, the quotient will be 3, is it fine? So, having obtained this, see in the form of algorithm. So, when you looked at this, so the last thing you have to divide by b, Unagra Cheda is b, Bhajita is divided. So, when you do that, so this is basically saying 92 has to be divided by 29. So, you get 3 as the quotient and 5 as the remainder. So, whatever is the remainder is basically x. Okay. So, now let us see. So, this equation, so this is x. So, n, the given number n is 49 times x. So, plus 7, and that fixes our y also as 8. So, finished. So, x is 5 and y is 8. So, one thing which you need to understand with reference to this algorithm is, so once you have one solution, you have infinite number of solutions. So, this is pretty evident. See, for instance, if x is equal to alpha and y is equal to beta is a solution, to, so the equation that we had was by minus c is equal to ax, then so x is equal to alpha plus bm and y is equal to, so beta plus am is also a solution m is any integer. So, this can be easily checked. So, where m is any integer. So, any choice of m has to satisfy, and therefore, it is pretty evident that we have infinite number of solutions to this. Fine. So, this is all the algorithm is all about, Kutarka algorithm. So, now I have to leave the Kutarka algorithm and then move on. In fact, what has been done is later, of course, Brahmagupta has discussed this, Aryabhatta is the first to discuss this Kutarka algorithm. So, Brahmagupta has also discussed this. So, Bhaskara has done, Mahavira has done. So, all other later astronomers have provided certain kind of modified version of this Kutarka, and so those will be covered when we discuss those texts. Now, I move on to give you a flavor of how this Jaina mathematics has been before, of course, this Mahaviracharya. Jaina tradition, in Jaina tradition it seems that this mathematics was also sort of considered as a part of their religious literature. So, it is in some sense like, I mean, see, we have this Jyotisham as a part of Vedanga. So, in fact there is a text called Vedanga Jyotisham. So, it basically deals with some kind of mathematics. So, there I think it is in a much more in fact they say there is a section called Ganitanu Yoga they say. So, in their religious literature itself. So, some of the ancient Jaina mathematical works are listed here: Jambudvipa Prajnati, Surya Prajnapti, Sthananga Sutra, Bhagavati Sutra, Uttaradhyana Sutra, Anuyogadvara Sutra, Triloka Sutra. Of course, Ganitasara Sangraha is a much later work. So, our knowledge of the early Jaina works are primarily based upon commentaries, as some of these original works have not even come to light. So, this is true of many of these literatures. It is very unfortunate that even today with all the sophistication that we have, so not much care has been taken to preserve these manuscripts. Okay. So, results of mensuration. So, I will just list a few of them. See, for your information, this Brahmasputa Siddhanta, we do not have good manuscripts. Aryabhatıya, fortunately we have plenty of manuscripts, and its commentary, Brahmasputa Siddhanta's commentary by Prithudaka Swami, there is only one, and even that is not accessible. So, that is how things are. So, it is a very sad state of affairs. Anyway, so let us come to this Jaina literature and some of these formula related to mensuration. So, I am just listing here. So, for instance, they say the circumference of circle is root 10 times the diameter. So, in fact, even Brahmagupta sort of uses this value. So, this is somewhat crude, as we know, compared to the value which has been specified by Aryabhata. Anyway, but for practical purposes, so this is how they have been using this. So, then area of a circle, so is 1/4 circumference time diameter. So, this is all right, but the value of circumference is not quite accurate. So, then they say chord. So, in fact, today morning we had a discussion at great length of the Aryabhata Sutra, right, Jashara Samvarga. So, that is all this is. So, it is basically the product of chords, they are same. Okay. So, Shara, so this is how it will be. See, if you consider this as chord, this is one Shara, this is another Shara. So, this is Shara as far as this is concerned, because this is bow, and if you consider this as bow, this is Shara. So, product of this will be the same as the product of these two. So, that is what it amounts to. So, this is stated in a different way, but that is what it amounts to. So, that is why this factor 4 comes here anyway. So, then Shara, see, so once you know the diameter and chord, will you be able to make a guess of Shara. So, this is a slightly different way, and there are various approximations which people have been trying, see, to obtain Shara given this Ja, to obtain Ja given Shara, and so on. So, there are various formulae which has been given by Jaina mathematicians. So, by Shara, so you should understand that it is basically r minus r cos theta. Okay. To give you a flavor of how the original verses are, so I have just quoted two verses. So, this is maybe in Prakrit, I do not know, but definitely not in Sanskrit, and I have tried to make a Sanskrit rendering of this, so that we try to understand this. So, see here, Triguniya Vasam. So, this is Trigunita Vyasa, okay, 3 times the diameter. Parihi, so it is Paridhihi, Paridhi is circumference. Okay. So, C is 3 times D. Then Dahagunak Thira Vama Moolam Cha. So, this is the, see, Cha is obviously and. So, Parihi is Paridhi. Paridhi he gives two expressions. One is Trigunita Vyasa, the other is dasha guna. See, dasha guna 10 multiplied by vistara should be this thing, vistara is diameter, okay. So, vistara varga moolam, so vistara is d square, so root of 10 times d square is also, so this is what they have stated, no. So, root 10 times the diameter. So, this is the expression for the circumference once you know the diameter. So, these are the two different forms in which they have given. Then paridhi vyasa turyam. So, in philosophical literature you will see there are 4 states. So, one is Jagrat, Swapna, Sushupti, and then they call Turyavastha. So, Turya is the 4th state. So, Turyam in the sense here uses 1/4, you understand. So, Paridhi Vyasa Turyam, okay. Paridhi Hatha Vyasa. So, Paridhi is C, Hatha is multiplication, Vyasa is diameter, Turyam 1/4 of that. So, that gives the Ksheta Phalam, this is what it says, Ksheta Phalam should be Kshetra Phalam, okay. So, Badara Sukshmam, so that is a bit difficult to Sukshmam is perhaps more accurate, okay. So, it is a Kshetra Phalam. So, this is the form in which we find, see some of these verses have been cited by Bhaskara also in his commentary to Aryabhatıya, and most of the earlier Jaina works are in this language, which is not far different from Sanskrit, but it requires a certain familiarity to figure out them. And this literature, Jaina literature, philosophical literature is also in this. Similarly, one more verse, so Ishuhinam Vishkambham. So, Vishkambham they always say Vikkambham, okay. So, Ishuhinam Vishkambham Chavugunitasu na Chaturguneshu na, okay. Chaturguna Ishuna, okay. Ishu is Shara. So, if we look at this, so if you know the formula it will be easy for you to decipher, otherwise it is not so easy. So, this so Chaturguneshu na, so multiply by 4 and he H suppose is Ishu, Dhanu, then this Hade should be Hate, Du is Tu, Jiva Kritihi, see. So, Jiva is card, so card square, so you can have this approximation and that is what this says. Then Bana Kritihi Shad Gunite, see. So, Bana Kadim Chahi Gunite, so Chahi Che in Hindi, you know, Chahi Gunite. So, Tutha Jude, Tatra Yute, Dhanukritihi Bhavati. So, Dhanukritihi is, Dhanuhu is arc. So, arc square is this. So, these are certain approximations, so which have been presented in Jaina works. So, finally, so this Jainas also have this notion of infinity expressed in slightly different ways. In fact, they speak of different kinds of infinities. So, but one should not simply compare with the Cantor's notion of infinity in our mind and then what they have spoken. I mean, that is not a good way of looking at things, but then what is interesting is, so they have spoken of different kinds of infinities, okay. So, today we have, so infinite number of infinities, so that is a different way. So, we have gone in a much more advanced way of analyzing infinity. Here, so they actually classify the number into Sankhyeya, Asankhyeya and Ananta. So, Sankhyeya is innumerable, Asankhyeya is uninnumerable, and then Ananta is sort of infinite, and infinite also they say, see, Ekataha Anantam, Dvidha Anantam, and then Desha Vistara Anantam, see. So, infinite in terms of area, one direction, two direction and so on, and infinite everywhere, Sarva Vistara Anantam and Shashvata Anantam. So, this has to do perhaps with the something which is eternal in time. So, eternality in terms of space, in terms of time, in terms of direction, I mean they sort of classify this in various ways. And so there are some interesting examples which Jainas have chosen to convey what infinity is. So, for instance they say consider a trough whose diameter is of the size of the earth, okay. So, consider a trough, so which is 1,00,000 yojanas. So, fill it up with white mustard seeds, imagine. So, filling a trough of the size of the earth and then with mustard seed you have to fill it up and keep counting them. Similarly, fill up with mustard seeds other troughs of the size of various lands and seas, okay. So, one is the size of the earth, still it is difficult to reach the highest enumerable number. So, this is just to give you a certain conception of what we are talking about when we see large numbers. Pardon? That I do not know. Okay. So, then so we have also this indices, see that is very interesting thing. So, they say see Jainas have discovered about logarithms also, but it is a bit difficult to figure out. See, first of all I must admit that I am not that conversant, and secondly even good editions and interpretations very clearly written things are not available. Certain articles are there, but it is all sort of based on certain other commentaries. But the point I want to convey is, so they talk of varga varga, ghana varga varga, see, so all that, see, so they discuss about various kinds of indices. So it is in this connection, so people say that they also talk about this logarithms, and I just skip this and to give you an idea. So what are the various topics which are discussed? So in any typical Jaina text, see parikarma. So this you might have seen when Professor Sriram had discussed about Mahaviracharya. So Vyavahara, Rajju, Rashi, Yavat Tavat, unknown quantities. So Vikalpa, of course permutation and combination. So Varga Varga and so on. So with this I conclude my session on Aryabhatıya as well as Jaina mathematics, the ancient Jaina mathematics, okay. So then we will have discussion on Brahmagupta and so on. Thank you.